Hi guys, welcome back to Championcraft, and this is the fifth video in the series of Prometheus Certified Associate course. And in this video I'm gonna discuss about Prometheus architecture. So let's start with a 1000-feet view of architecture. Consider we have three servers: server 1, server 2 and server 3. And in Prometheus we have three main components: the component 1, component 2 and component 3. The first component is responsible for scraping metric data. So what it will do is, it will go to each and every target and scrapes the data and brings those metrics to Prometheus server. Later the second component, which is responsible for taking those scraped metrics and stores them in something called TSDB, time series database. Once those metrics are stored in TSDB, as an end user, we can leverage HTTP server which is running in the Prometheus server to run PromQL in order to get customized and required data from TSDB. Now let's discuss about in detail architecture. I already explained you guys about these three main components. Let me explain about exporters now. Prometheus expects each and every server to export metrics in a certain format, but natively not all servers will generate metrics which are suitable for Prometheus. So to make it possible, what we will do is, we will run something called exporter in each service. The job of exporter is to collect insights from the server and format them such that they are understandable for Prometheus server. What is push gateway? One point we should note is, let us consider a server is running continuously. So how Prometheus will work is, for every regular intervals of time, consider for now as an example, consider there is regular interval of time as 15 seconds. So for every 15 seconds, Prometheus goes to the target and scrapes the metrics and stores them into TSDB. Those metrics can be from the server or the application running inside the server. If we concentrate on the collecting metrics from the application running inside the server, if the application continue to run more than 15 seconds, Prometheus will go to the application and scrape the metrics for at least once. But what if the application is not live for at least 15 seconds? Let us consider the application started at 0 seconds and killed at 10 seconds. Soon the Prometheus server goes to the application is already dead, because Prometheus server reached the application in 15 seconds, but the process already died at 10 seconds. So we lost some metrics. So to handle this kind of scenario, what this application will do is, before it dying, it will push the metrics to something called push gateway. Now the Prometheus won't go for the application, rather it will go for the push gateway. That is how the push gateway will work. Next, coming to the service discovery. Let us consider a scenario where you have three servers hosting your application. So the Prometheus have those three servers endpoints, so that it can able to go to those three servers and scrape metrics at regular intervals of time. What if one server goes down and you replaced that server with a new server? So now the endpoint got changed, but the Prometheus didn't know it. So in order to make it available for Prometheus, you need to come to the Prometheus and you need to configure the new endpoint as well, right? So it is a tedious process. If it is one or two servers, it is fine. What if a system has thousands of lakhs of servers? It is very hard for us, right? So to overcome this, we have something called service discovery. The responsibility of the service discovery is to maintain all the target endpoints that Prometheus has to scrape. And next, we have something called alert manager. One important point is, Prometheus can detect alerts, but it can't send an email or a Slack notification or an Outlook email directly. To do that job, we need something called alert manager. So the Prometheus will fire an alert. The alert manager will catch the fired alert and responsible for sending notifications. And coming to the Prometheus web UI, so the Prometheus have the ability to use the PromQL in order to fetch some data from TSDB and plot them nicely. And this can be offloaded to some other visualization tools like Grafana. How Prometheus will collect metrics from its targets? Basically, it will do HTTP requests for each of its target at the endpoint of /metrics. However, this /metrics is not very rigid. Prometheus will allow us to customize it for each server. As I said earlier, not all servers by default export metrics that required by the Prometheus format. So in order to make it possible, we installed something called exporter in each server. The job of the exporter is to collect insights from the server and format them in such a way that Prometheus will understand. Prometheus has several native exporters, including Node Exporter, Windows Exporter, MySQL Exporter, Apache Exporter, and HA Proxy. Can we monitor application metrics like number of errors per exceptions, latency of requests, job execution time? Well, yes, that is also possible using Prometheus. Prometheus comes with something called client libraries, which enable us to expose any application metrics you require Prometheus to track. These client libraries provide language support for Go language, Java, Python, Ruby, and Rust. Thank you guys, that's it for this video. See you in the next video. Thanks for watching. Bye bye.